As an introduction to Euclid's elements, I'd like to note before you start that this is indeed not rigorous. People have fought over this for a bit over 2,300 years. I would just like to take you through the path of history in the most rigorous fashion that time has to offer. I shall torture you, and then we move on to Hilbert's, Tarski's, and Birkhoff's axioms after like 23 episodes. In addition, I'm in a study room in public space, and thus I'm trying to keep my voice down. This is also my first video, so I'm really sorry for any inconvenience. I would also like to note that a complete understanding of what each of the definitions means is not required to move on to the next episodes, in which a lot of ideas shall be expressed naturally later on. This is simply an episode where I decided to plant bombs everywhere so that you could be more mentally aware of future issues that may occur. Please comment down all issues that you find and timestamp it. There may be some that are unintentional as well, and I certainly will be looking into the comment section to point out if I'd actually made some mistake. If there are a lot of them, I might as well make a follow-up video on them. I now demonstrate one of the earliest frameworks of geometry. 1. A point is that which has no parts. What Euclid possibly meant was that it shall be indivisible. It cannot be broken into smaller parts, for it is the most fundamental unit of relation. Something similar to what I have described should have been turned into an axiom. However, Euclid never did that. We shall define points as the one of the most primitive elements within this framework, in which shall contain no magnitude, solitary existence on its own. Therefore, there exists no dimension. We shall define dimensions as an independent axis of relating various measurements into magnitudes. For the context of being within Euclid's elements, we shall only classify 3 dimensions: length, breadth, and depth. In which when there exists depth, we assume there exists breadth and length. When there exists breadth, there exists length. This is a confusing topic for now, and one that most likely will not be important for the next episodes, in which I shall simply leave it here and leave you confused if you didn't understand what I meant. 2. A line is breadthless length. Another primitive entity that we shall coin, and don't give me something like a line is a set of points or something like that. We assume from things that we are given, and set theory is not one of them. There are 2 types of lines I would like to describe here: a straight line and a derived line, not straight. As a starter, we can't really prove if a line is straight with what Euclid has given us, and as we move to later, you may realize a straight line is explicitly defined as a subcategory of a line. And thus I shall imply a second kind of line, a derived line that is not straight. For now, you should keep this concept vague, for you will slowly understand how these lines are created. 3. The extremities of a line are points. We shall define a boundary which allows us to measure the magnitude between 2 points, in which the end points are called extremities. There isn't much reason to go into that within Euclid's elements, so you shall coin it as another primitive element. And again, we will cover all of these ideas later after we complete Euclid's elements, or maybe in the future. You could choose to complete mathematical logic first, and then the series of Tarski's, Hilbert's, and Birkhoff's axioms, and then come back to episode 2 of the series. 4. A straight line is a line which lies evenly with the points on itself. What Euclid meant is probably that it is uniform in every single way, in angles, distribution, and so on. You may realize by now that Euclid's elements, in contrast to modern frameworks, focuses largely on intuition for the definitions and graphical proof, or what phenomenon occurs with the given axioms, in which all other ideas, the definitions, are phenomena that naturally occur given that these fundamental concepts are satisfied. In which now I introduce the first 2 postulates. Postulate 1. To draw a straight line from any point to any point. Given 2 points, we are able to connect them and form a straight line, in which the shortest distance between 2 points will always be a straight line in Euclidean geometry. Postulate 2. To produce a finite straight line continuously in a straight line. Given a finitely bounded straight line, we could always extend it in either direction, continuously. In which, we shall note that the 2 postulates which we just introduced are more on what transformations are we allowed to do based on the definitions or fundamental identities that were proposed. 5. A surface is that which has length and breadth only. 6. The extremities of a surface are lines. On each bounded surface in whatever orientation there shall be lines, and thus shall be named to be the extremity of the surface, in which the 2-dimensional object collapses into a single dimension. Now, Surely I've confused you even more on what a dimension is if you haven't explored much of it on your own. I would just like to note to you it is already very draining for me to propose such an unrigorous framework, and dimension never was part of Euclid's elements to begin with. This is again why it is important to keep all of these problems in your head. Try to find as many holes as possible. After about 40 or so episodes, most of them should be resolved, or perhaps you will be left with more questions, potentially even ideas that you could propose to be revolutionary. 7. A plane surface is a surface which lies evenly with the straight lines on itself. This is a flat surface in which within two dimension, given 2 points terminating at any point within the figure, there shall be no position on the line that constructs the surface shall be curving. Most likely you won't encounter one, and when you do encounter one, it is most likely using a derived line as a line used to construct the surface. And yes, this is also intentionally ambiguous. 8. A plane angle is the inclination to one another of two lines in a plane which meet one another and do not lie in a straight line. 9. And when the lines containing the angle are straight, the angle is called rectilineal. To simply say, a plane angle is any kind of angle formed by any kind of lines, in which Euclid used the word inclination to define an angle. In which angles that are rectilineal are those we traditionally encounter. In which it is more appropriate to use the word rotation rather than inclination, for incline doesn't seem to be a good way to describe something that is past the point of two right angles. Intentional wording here. 10. When a straight line set up on a straight line makes the adjacent angle equal to one another, each of the equal angles is right, and the straight line standing on the other is called a perpendicular to that on which it stands. When two perpendicular straight lines intersect each other, they form four right angles, for they are all equal, in which we introduce postulate 4, that all right angles are equal to one another. Certainly you would like to use some kind of measurement such as degrees or radians to measure the angle, but we don't have that available yet, and it is something that we will be proving. 11. An obtuse angle is an angle greater than a right angle. 12. An acute angle is an angle less than a right angle. On a horizontal plane formed by two lines, in which the vertical line terminates when reaching the horizontal line, it shall form two right angles. When we rotate the vertical line slightly to the left, the angle on the right would be greater than the angle on the left, making the angle on the right an obtuse angle, and the angle on the left an acute angle. If we inverse it, it would be the same. Rotating the vertical line to the right would make the angle on the left an obtuse angle, and the angle on the right an acute angle. 13. A boundary is that which is an extremity of anything. Late definition, but should be self-explanatory enough if you understood definitions 6 and 3. 14. A figure is that which is contained by any boundary or boundaries. So we coined the idea of surfaces earlier, but not figure, so we could probably assume that figures are surfaces and lines with a bound with the previous definitions that we had. Postulate 3. To describe a circle with any center and distance. The strict definition of a circle is to form a line as the boundary for a surface, for the surface is the circle, the boundary being circumference. The distance used to describe the circle is also the distance between the circumference and the center, which are commonly referred to as radius in modern terms. Also, the circumference is continuous, thus does not break at all. 15. A circle is a plane figure contained by one line such that all the straight lines falling upon it from one point among those lying within the figure are equal to one another. 16. And the point is called the center of the circle. These two definitions further ensure the fact that a circle has to be a plane surface, for this condition was not specified in postulate 3. 17. A diameter of the circle is any straight line drawn through the center and terminated in both directions by the circumference of the circle, and such a straight line also bisects the circle. Radius multiplied by 2, for it was coined that one point among those lying within the figure are equal to one another, and that point is called the center of the circle. Since the point of bisection shall always be at the circumference, it is indeed twice the radius. 18. A semicircle is the figure contained by the diameter and the circumference cuts off by it. And the center of the semicircle is the same as that of the circle. The word cut in Euclid's element is basically the idea of without consideration of the other part that was cut off. 19. Rectilineal figures are those which are contained by straight lines, trilateral figures being those contained by 3, quadrilateral those contained by 4, and multilateral those contained by more than 4 straight lines. Recall that in definition 9 that rectilineal are defined basically the existence of all angles formed by straight lines. The first part of definition 19 is very specific. For example, why don't we just say the lines used to contain the figure are straight? Figures imply that there exists a boundary in which it is naturally all straight lines given the term figure formed by straight lines. If you were to provide an angle within that is not contained by straight lines, then it is automatically not a figure formed by straight lines. Note, don't read. Contained by may semantically allow for a non-rectilineal interior, which could create ambiguity. A stronger phrase like figure formed by straight lines would force internal rectilineality. Rectilineal figure being contained and not bounded as an extremity imply that it could have non-rectilineal properties within. This is actually something that I am confused with. We shall continue on with this anyhow. Please explain this to me if you could. GPT gave me in response that Euclid probably doesn't want overdetermination, but oh well. Trilaterals are triangles, 3 sides, 3 angles. Equilaterals are those with 4 angles and 4 sides. More on them in the next definitions. 20. Of trilateral figures, an equilateral triangle is that which has its 3 sides equal, an isosceles triangle that which has 2 of its sides alone equal, and a scalene triangle that which has 3 sides unequal. 21. Further, of trilateral figures, a right-angled triangle is that which has a right angle, an obtuse-angled triangle that which has an obtuse angle, and an acute-angled triangle that which has its 3 angles acute. More rigorous proof on definition 21 later. Proposition 1.32. All you have to know for triangles for now is that there exist 2 sides that are same in isosceles, all sides equal in equilateral or equal-faced, no side equal in scalene. 22. Of quadrilateral figures, a square is that which is both equilateral and right-angled, a rhombus that which has its opposite sides and angles equal to one another, but is neither equilateral nor right-angled. And let quadrilaterals other than these be called trapezia. These are the quadrilateral figures that you'll encounter, in which we shall not go any deeper besides knowing that they have a name, just like triangles. 23. Parallel straight lines are straight lines which, being in the same plane and being produced indefinitely in both directions, do not meet one another in either direction. Postulate 5. That if a straight line falling on 2 straight lines make the interior angle on the same sides less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side of which are the angles less than the 2 right angles. Parallel lines do not intersect, all other straight lines do. Take definition 23 as a phenomena which describes what the parallel line is, while postulate 5 defines what it could do.